Hey guys, so we are going to go over degrees and radians today. We are starting to switch gears and we're going to go into more of our geometry type of standards in Algebra 2, but don't worry. I think we are going to be fine. A lot of you were in geometry last year and school shut down in March and April, and so you might be a little nervous as we head into these geometry standards, but I think we're going to be fine. Today, we're just getting started with degrees and radians, very basic. If at any time you feel like things aren't meshing and we've got holes and gaps, please let me know and we can navigate those together. So first, I've got some basic definitions before we get into degrees and radians. First is angle rotation, and that is an angle that is formed by the starting and ending positions of a ray as it rotates about its endpoint. So let's talk about a ray. Remember, a ray has an endpoint and one arrow. Definition, good thing for ACT. So if I rotate it, now I have a angle rotation. Exactly like it sounds. Let's talk about standard position. So standard position is going to be at the beginning or our initial side, which is always going to be the positive x-axis. So if I had a coordinate plane, 0, 0, we're talking about the positive x-axis. We'll have a ray. The endpoint will be 0, 0, and that will be our standard position. We will always start there for our degrees and our radians. Counterclockwise. So counterclockwise is going to go up, around, to the left. Clockwise is going to go up and right, like a clock. Okay. Counterclockwise is going to be a positive angle measurement. If we go down and around, negative measurement. Let's look at what we got. Number 1, sketch 120 degrees. So standard position will always start here on the positive x-axis. And so let's review a few things. In a bell ring or a warm-up, I would have asked, hey, what's 90 degrees? Your right angle. What's 180 degrees? A full straight line. Because if you had a 90 right angle and a 90 right angle would make 180, and you'd go all the way over. A full circle would be 360 all the way around. So some of those things will be helpful. So we're going to start here on the positive x-axis and let's sketch 120 degrees. Now I want to be positive, so we're going to go up and over. If this is 90 and another 90 makes 180, that's too much. So let's talk about, let's break down this 90. If I broke it into thirds, and this is all important for later, that's 30, 60, 90. Another third into the next quadrant would be 120. So I had 30, 60, 90, 120. Let's do it in orange. So we started here, and we're going to rotate up. And that's going to be our 120. Okay, so we went up to 90, and then a third of the way through the next quadrant to make 120 degrees. Let's look at number 2, sketch 90 degrees. This one's very straightforward. Always standard position, positive x-axis. I'm going to rotate it straight up. I'll show all our final answers in orange. How about that? So we rotated up 90 degrees. Number 3, sketch negative 140 degrees. We're still going to have a standard position starting with the positive x-axis. We want negative, so we're going to go down and around. So we already know straight down, that would give us 90. All the way across would be 180. That's too much. So what do I need to do in between? If we did A third of the way, that's another 30 degrees, 120. And another 30 degrees would be 150. That's too much. So maybe somewhere in between. Halfway between the quadrant here would be 45 degrees. So 45 plus 90 is 135. So we need something just right in between there. So I'll have my standard position at positive x-axis, and we're going to go somewhere in between. Now the directions say just sketch. So that's all we're doing, 140, negative 140. On Delta Math, you're going to have like an estimate and you rotate it, and it just has to be between 10 degrees too much or 10 degrees too little. You have some wiggle room there, and so you're just sketching. Number 4, sketch a negative 45 degrees. So standard position, positive x-axis. Negative, we're going to go down and around. We were just talking about halfway between 90 is 45 degrees, and that's exactly what I need. So standard position, starting place, positive x-axis, and we're going to go halfway down to make negative 45 degrees. Okay, so just sketching those. Positive, up and over, negative, down and around. Next part, coterminal angles. So coterminal angles, think about the word co-worker, you work together, coterminal. So terminal means like end. In fact, like the airport, there's airport terminals where your flight ends. So these are going to be angles that end together. They have the same end position. Let's see what the definition says. It's a different angle that shares the same terminal side or ending side, and it can go in the opposite or same direction. It can be another positive angle or it could be a negative angle. To find coterminal angles, you're going to add or subtract 360. So number 5 here says 135. So let's sketch that. Starting position. If I go straight up, that's 90. If I go all the way, that's 180. That's too much. If I go straight in between, that adds 45. And 45 plus 90 is 135. So that's what we need. So let me sketch that. Here's our 135. So I want a coterminal angle. I want another angle that ends at that same place. I'm going to do in red. I want another angle that would end there, but has a different measurement. Now, the direction said that I can just add or subtract 360, and these are super easy. So take like 135 and subtract 360. What do we get? We'll get a negative 225. So if I take a negative rotation, let's do that in like the pink color. If I start in the starting position, I rotate down and around negative 225 degrees, it ends in the same place. Okay, so that is one of your coterminal angles. We'll say equals negative 225. Is that the only one? No, we can have more. I think this lesson we really talk about just positive and negative, but I could add 360 and make it bigger. I could add another 360 and make it bigger. It can be bigger than 360 or smaller than negative 360. You can have multiple coterminal angles. So hopefully we'll get a chance to talk more about that coming up. Number 6, negative 315 degrees. So let me start at my positive x-axis for our standard position. Negative, so we're going to go down and around. Well, I know I'm going to need more than negative 180 if I go down this way. And if I keep going, that's going to be another 90, which is 270. Got to keep going. If I do another 30, that's negative 300. Another 30 would be negative 330. Here, standard position, positive x-axis, we're going to go down and around halfway between here to give us negative 315. Now the question was asking, find another coterminal angle. So I want to find another angle that would end right there. My directions say I can add or subtract 360. So let's take negative 315 and add 360, which would be 45 degrees. And let me show you. What do we use? The pink color. So standard position, if I just went up 45 degrees, right halfway in between, voila. They end in the same position. You could also do like a check of 315 plus 45 is 360. They end in the same place. All right, so our coterminal angle for this problem is 45 degrees. And there's more. I could do another full 360 rotation and the bigger angle would end in the same place. These are really easy. They might seem complicated right now, but I promise when you see the practice on Delta Math, you just add 360 or you subtract 360. It's that easy, I promise. Okay, so at the beginning of the notes, it's titled Degrees and Radians, and you may have been like, what's a radian? Okay, so before we dive into that, let me give you the illustration of measurement. If I wanted to measure the distance of something, I have lots of options. I can use inches, or I could use centimeters, or I can use feet or yards or meters. So we have the US customary system and we have the metric system, and we also have different units to measure, right? All depending on what I need to measure. Same thing is true for angles. So you've grown up your whole life that angles are measured by degrees, end of story. Well, there's actually another unit of measure for angles called radians. And so we're going to start digging into radians. For this first lesson, we're just going to be converting degrees to radians or radians to degrees. So it's like changing feet to meters or meters to feet kind of thing. So here we go. It says here at the top of your notes, radians, like degrees, is a way to measure angles. Just another way to measure it. Some definitions here for you. To memorize, 180 degrees is equal to pi radians. So like pi, like a number of radians. 360 degrees would be equal to 2 pi radians. So if I had 180 plus 180 is 360, right? If I have a pi plus a pi, I have 2 pi, right? Okay. And then here's your rules to go convert something to radians. Multiply it by pi over 180. To convert to degrees, we're going to multiply it by 180 over pi. I got you. Also, last thing here, we are going to have radians. We'll have pi in the answer. Do not give me decimals. So pi is 3.1415927 something. I used to try to memorize more and more digits, but it's a irrational number. It's a decimal that never ends, never repeats. So if you start trying to give me a decimal form, you have cut off that decimal's tail and you've rounded it off and it's no longer equivalent. So all of your answers are going to have pi in them. Capiche? Capiche. Let's look at it. First one we're going to do is convert our degrees that we are comfortable with, that we've lived with our whole lives, degrees to radians. So it said, if I wanted to convert it to radians, I'm going to multiply by pi over 180. So I'm going to take 20 degrees. I'm going to multiply it by pi over 180. Now I'm going to give you a memorization tool to help you know which one do I multiply what? Okay. Well, we just said radians are going to have pi in the answer. So when I multiply this, what's going to happen is I'll be able to cross cancel my numbers here and pi will stay. All right, so let's talk about that. So we're going to simplify 20 and the 180, they will simplify and reduce to 9. And so we just have pi over 9 radians. Final answer. Number 2, we're going to convert negative 315 degrees to radians. You can do negatives too. We're going to multiply by pi over 180. So I want a pi in my final answer. I'm going to go to the calculator and divide negative 315 and 180 and get a reduced fraction. Most of these are going to be fractions with pi. So let's go to the calculator. I'm going to have a calculator page and do negative 315 divided by 180, easy peasy, hit enter, negative 7/4. So you have negative 7 pi over 4. Okay, don't lose your pi. Okay, final answer. Number 3, change 90 degrees to radians. I want pi in my answer, so multiply it by pi over 180. You can simplify this one probably in your head. Pi over 2. I just reduced. Pi over 2 radians. Done. Number 4, let's go backwards. Convert these radians to degrees. So we have negative 3 pi over 4. We're going to change it to degrees. On the notes, it says multiply it by 180 over pi. So I'm going to give you a memorization tool. How do you know which one to multiply by? Well, we're starting with radians with pi, and I'm going to degrees. I don't need pi. So I've put pi in the bottom so it will cancel out. Capiche? From here, you can use your calculator if you want to help you simplify and reduce this so we can get some degrees. When you're multiplying fractions, you go all the way across. You multiply across the top and then multiply across the bottom, and you would divide them. So I'm going to do negative 3 times 180. I'm going to go ahead and hit enter, and then divided by 4. Enter. Negative 135 degrees. Number 5, pi over 8. I'm going to change it to degrees, so multiply by 180 over pi. Put pi in the bottom so it cancels out. You can use your calculator to help you simplify. 180 divided by 8. 45 over 2 is not a degree, so let's do Control Enter will automatically approximate the decimal, so 22.5 degrees. Number 6, 2 pi over 5. Multiply it by 180 over pi. I put pi in the bottom so it'll cancel out and I can have degrees. I can use the calculator to get this done. I'm going to do 2 times 180, multiplying across the top for my fractions here, hitting enter, dividing by 5, enter, 72. Okay, converting degrees to radians, radians to degrees. Again, radians is just another way to measure angles. And so these are equivalent. It's like measuring with feet or measuring with meters. Customary or metric. This is just degrees and radians. Let's look at a few more questions to wrap up our lesson. Number 7, find an angle between 720 degrees and 1080 degrees that is coterminal with negative 30. So a lot of students read this question, they're like, wait, what? All right, all it's saying is find something between these numbers that's coterminal with negative 30. So earlier we were talking about coterminal angles, and it said just add or subtract 360. So take negative 30, and we want it to be between 720 and 1080, so a positive number. So let me add 360. What do I get? 330. Is that between 720 and 1080? No. Okay. So add another 360. What do you get? Add 690. Is that big enough? No? Add another 360. What do we get? 1050 degrees. Is that big enough? Yeah. Awesome. There is your answer. It is an angle between 720, 1080 that's coterminal with negative 30. If I graphed it on the coordinate plane, it would land and it would have the same terminal side as negative 30. Let's look at another one. Number 8, find the two nearest positive coterminal angles with 51. Find the two numbers that are as close as possible and positive with 51. So take 51, add 360. I'll get 411 degrees. There's one answer. I'm supposed to have two. I'm going to add another 360. Find the next positive coterminal angle. Gives me 771 degrees. Two positive coterminal angles with 51 degrees. Number 9, find the nearest two negative coterminal angles with 400 degrees. Guess what I'm going to do? The same thing, but I need it to be negative, so let me start subtracting 360. 400 minus 360 would give us 40 degrees. Is that negative? No. Keep going. Subtract 360 will give us negative 320. Does that work? Okay. I need two answers, right? So subtract another 360 and get negative 680. Two negative coterminal angles with 400 degrees. All right, so final recap. We talked about just sketching our angles. So positive angles, everybody starts at the positive x-axis as the starting position, standard position. For positive goes up and over, negative goes down and around. To do those measurements, we will be working with degrees a lot more. So if the 90s and the 45s and the 30s and the 60s and 180s and all those things that I said earlier, if you're like, whoa, we're going to keep working with these and you're going to be familiar with them as well. We talked about coterminal angles end in the same position. We're going to talk later about bigger numbers. That coterminal can also be two loops around and bigger than 360 or negative, smaller than negative 360. And then the last part of our lesson here was converting between degrees and radians. We're going to be using that a lot as well. So practice that, head over to Delta Math, finish the practice that goes along with this lesson, and we'll move forward to the next lesson for the week.